Hello everybody. In this lesson I will discuss an extremely difficult rider on the theorem the perpendicular drawn from the center of a circle. Example 3. In the diagram below, KT is a chord of a circle O. OC is drawn perpendicular to KT and cuts KT at B. PO is equal to X and PC is equal to Y. Number 1, determine PT in terms of KT. So you can say that PT is equal to half KT, and your reason, line from center perpendicular to chord. What does it do? It bisects the chord. Number 2, prove that KC squared is equal to 2xy plus 2y squared. Now this is a huge one. Let's start. We start by saying kc squared is equal to pc squared plus kp squared, and Pythagoras gave us permission there. Now we are working in triangle KCP, if you wondered what was going on there. Then we can also say kp squared is equal to OK squared minus OP squared, Pythagoras. So I was working in triangle KOP. And if you look at this, in triangle KOP, we get OK squared, the hypotenuse squared, is equal to KP squared plus OP squared. And then what I did was I made KP the subject of the formula, so OP squared walked across and became negative. Then in the next step, what I did, it was this step, and now I'm there. In the place of KP, I substituted OK squared minus OP squared. Then but OK is equal to OC. So in the next step, why? Because they're both radii. Let me show you up here. OK, there you can see is a radius, and OC is a radius. So therefore they are equal. So in the next step, I said that KC squared is equal to PC squared plus, and then in OK's place, I substituted OC minus, and now you're going to say, now what happened to OP? Let me show you. OP is equal to, and if you have a look at the sketch, there's OP. It's equal to the whole of OC minus CP. There you can see what happened there. That is what happened there. Then in the next step, what I'm going to do is I'm going to just erase all of this, and then I will show you. Let me get my pen back. All right, here in this step, this is the same as in algebra. You've got a minus b squared, and you can write that as a minus b, and then you can multiply it out and you get a squared minus 2ab plus b squared. And if you look at the next step, there's your PC squared plus OC squared and a minus, and then it was this bracket OC minus PC that I wrote twice, and I multiplied it out and I got that part over there. In the next step, I'm going to multiply in this minus. So let me show you what happened. So the whole thing, right from the beginning, from there, will be the step PC squared plus OC squared minus OC squared plus 2OC times PC minus PC squared. And then PC squared minus PC squared is nothing. OC squared minus OC squared is nothing. So you're only left with 2OC times PC. And then in the next step, you can see that OC, have a look at the sketch there. OC is this whole length. And can you see it consists of OP plus PC, which is x plus y. And then PC was given just PC, that it's y. That's where the y comes from. And then, so let me just rephrase that one. OC is x plus y, PC is y. And then in the next step, you multiply in the 2 and you multiply in the y, and you get on the left-hand side, well, still kc squared is 2xy plus 2y squared. In the next lesson, I will discuss the theorem angle at the center. Click on the video in the left-hand corner to take you to the next lesson.